All right, what up, guys? Let's get going. First video in a while. Time to do our percent and exponents practice. Let's get going. For the following problems, find the percent change from the first number to the second. Describe whether it is a percent increase or a percent decrease. Now you'll notice I had to actually read the entire problem. You gotta read the entire question on these guys. There's kind of no way around it. You gotta do the actual reading. So in this case, you are told to find the percent change, and we gotta say whether it's a percent increase or decrease. For every single one of these formulas, you're going to have to do two steps. Step number one, you're going to have to go ahead and find the growth factor. The growth factor is always going to be a fairly straightforward formula to finding it. You simply want to go ahead and do the new divided by the old, or in other words, the second number divided by the first number for each one of these. Once you've figured out what the growth factor is, your second step is to find the actual percent change or change of percent. That is going to be the 100 multiplied by the growth factor minus 1. For all these questions, I'm going to be doing the calculator work off screen. However, if you need help with the calculator, let me know. I would love to help you out either in class or what we're doing. Here we go. Growth factor, new divided by old. So we have our growth factor is going to be equal to the new number 40 divided by the old number 30. And if you plug it into a calculator, you get 1.3333. I go to 4 decimal places for these questions. After you have done that first step of finding the growth factor, our second step, kind of running out of room, so I'm going to go second step here. Our second step, we have to find our change of percent. It's going to be equal to 100 multiplied by 1.3333 minus 1 for a final answer of 33.33%. And a percent increase is anytime this is a positive number. Percent decrease is if it's a negative. So this is an increase. And there we go. Letter B, same exact idea. We're going to be repeating this process quite a bit. So our growth factor here is going to be equal to the 600 divided by 75. 600 divided by 75 is exactly 8. And our change in percent is going to be 100 multiplied by 8 minus 1, which is 700%. And again, that's a positive number, so the word is increase. The next one's got a dollar sign in it. The dollar sign doesn't really mean too much, just means it's money. It's a very common thing for people to say, hey, there's $20 off. What's the percent off? Good question to know, especially if you're kind of thinking about, should I use the $20 off coupon or should I use the 15% off coupon? Which one's going to give you more money? Depends on the situation. And this is a way to figure that out for yourself. And in order to do this, we're going to go ahead and start off with our growth factor. That's going to be 49.99 divided by 69.99. 49.99 divided by 69.99. Turns out this guy is going to be 0.7142. And our change in percent then is going to be 100 multiplied by 0.7142 minus 1. And let's see, minus 1, and we're going to get an answer of negative 28.58%. And that is a decrease because it's a negative number. So 28%, so this $20 off is 28% off. So if you're given a choice of $20 off or 20% off, in this case, we take the $20 off. From 1257 to 8400. So our growth factor here is going to be 8400 divided by 1257. Definitely need a calculator for that one. And that one's going to be 6.6826. And our change in percent then is 100 multiplied by 6.6826 minus 1. And that's going to be 500 68.26%. Oh, I forgot the word increase in there. It's a positive number, so it's an increase. There you go. Increase. For sure. We finally finished our first question. Let's move on to the next problem. Number 2. While at Tempe Marketplace, you decide to buy a new backpack that is on sale for $44.99. Tempe has a sales tax rate of 8.1%. What is the final price you pay for your new backpack? This is a rewriting of the original. So we had this equation up here, the growth factor equals new divided by old. Another way of writing this is to say that the new is equal to the old multiplied by the growth factor. So in this case, the final price you pay is what we are looking for. So we are looking for this new price, and that's going to be the old price of $44.99, but we don't know what the growth factor is. So we need to figure out what that growth factor is. The formula we can use for that growth factor is going to be 1 plus the change in percent divided by 100. In this problem, our change in percent is that tax rate of 8.1%. So 1 plus 8.1 divided by 100. And using our calculator, our growth factor will be 1.081. Plug that guy in here. Use a calculator to figure out what that new price is going to be. Definitely need a calculator for this one. 44.99 times 1.081. And we're going to go ahead and get a grand total. And I like to use the dollar sign because it is money. 48.63, 2 decimals on this problem instead of 4 because it is a pennies question. You have to actually round to the nearest whole cent. Continuing on, this guy down here at the bottom, when buying online, you sometimes don't pay sales tax. You decide to buy a new pair of fancy headphones, which cost $189.99. But you have a 25% off coupon. What was the final price you pay? So you're not paying any sales tax here. You just have your 25% off coupon. So 25% off, remember that this means this is a decrease, which means that when we're doing our growth factor formula, we need to make sure we're doing 1 minus. So like this problem here, we did 1 plus the percent change. This one's 1 minus 25 over 100 because of that percent off, that coupon idea. Using your calculator, you get 0.75 as the growth factor. And yet again, use the same exact formula. The new amount is the old amount, 189.99, multiplied by that growth factor of 0.75. As a reminder, I use the word growth factor interchangeably with the other word, decay factor. This is technically a decay factor because it's going down. Remember, the word factor just means multiply, so growth means go up, decay means go down, but not too big a deal. It's the same exact formulas, same exact stuff. Just goes in a different direction. You get $142.49 as your final price for these pair of headphones. Not a bad deal. So in this case, if you were at $25 off versus 25% off, definitely take the percent off. Let's go to the next page. Oh, that's a different assignment. Here we go. So you decide you have to buy the massive teddy bear, which retails for $89.99. You're buying because you have a 30% off coupon in addition to a 5% off special on your credit card. The sales tax for your buying, 7.9%. What is the growth factor for the 30% coupon? So your 30% coupon, that's percentage off. So it's a subtraction. So the growth factor is 1 minus 30 over 100, which is simply 0.7. Okay. Box it. 0.7. What is growth factor? 5% off special. Well, it says the growth factor is 1 minus 5 over 100. Again, is a percent off. That's going to be 0.95. There's our second answer. What is the growth factor? Is 7.9%. Sales tax. Sales tax means we're going up. So this time we do have a 1 plus 7.9 divided by 100, which is 1.079. And it says, what is the overall growth factor? You got to multiply all of them above. That is what you actually do. That is what those cash registers of the store are doing. They're multiplying all these growth factors together. So 0.7 times 0.95 times 1.079. Multiply all those guys together, and we get 0.7 17535. I guess we only had to go to 4 decimal places, so you didn't need these last 2 decimals. Cross those off. What is the final price you're paying for the teddy bear? So same exact idea. The new is always equal to the old, which is 89.99 multiplied by that 0.7175. 4 decimal places is fine. So 0.7175 multiplied by 89.99, and you will end up with a final price of your teddy bear of $64.57. Easy peasy. Here we go. The population of Phoenix, Arizona increased following an exponential model with a 2.76% increase in size each year from 1960 to 2000. These are actually accurate numbers. I looked these up. These are all accurate numbers. That is the actual increase in percentage, and it basically followed this every year. Slight fluctuations, but not too much. So find the 1-year growth factor. So the 1-year growth factor, use exactly the same formula that we've been using. 1 plus that change in percent divided by 100, and that's going to be 1.0276. Again, 4 decimal places is requested. Find the 40-year growth factor. So this is the first time we have to use slightly different thinking. So 1-year growth factor is after 1 year. 40 years is if you multiplied every single year 40 times. So 1.026, 1.0276, 1.0276, 1.0276, 40 times. So this growth factor is going to be 1.0276 to the 40th power. So you do have to do that guy to the 40th power. So 1.0276. You raise it to that 40th power. If you do it correctly, you'll get 2.9714. Again, 4 decimal places. Find the 40-year percent change. So the 40-year percent change is how much the population has changed percentage-wise. And here, it basically says the population multiplied by 3 over the course of 40 years. But the actual percent change is going to be that change in percent formula, 100 times 2.9714 minus 1, and that's going to be 197.14%. So 197.14% increase. I forgot my word there. Caught from the team. All right, letter D. If the population was 1.32 million people in 2000, to find a function G with input T that gives the population of Phoenix, Arizona in years after 2000. So be careful here. This is after 2000. So, I mean, really careful is letter E, but here we go. So we have G with input T. So G of T is equal to 1.32 million people. Remember, this is in millions. Multiplied by, and in general, all these formulas, what they should look like, just in case you don't have it written down, should basically look like this. F of x is equal to the initial value multiplied by the growth factor raised to the power of x. In this problem, 1.32 million is our initial value. Our growth factor, we just figured out our year growth factor. So our yearly growth factor is this 1.0276 that we found. And letter T for the years here. What I was talking about earlier about being careful is you have to use your function to find the population in 1986. 1986 is before 2000. So it is 14 years back. So G of negative 14 is what you had to plug in, 1.32 multiplied by 1.0276 to the negative 14th power. And again, that is in millions. So we will have to convert away from millions at the end of the question. So we get 0.90164.7 going to 6 decimals because this is in millions, right? So if you're actually in millions, a million, let's write a million. A million looks like this. A million has 6 zeros, so it's the same as moving the decimal place 6 to the right because this is in millions. So the correct answer is 901,647 people. are in Arizona. So just remove that decimal, move it 6 to the right, and that's why I went 6 decimal places there. The other option for this question would have been back at this step right here, instead of writing this one in millions, what you could have done is you could have said, hey, it's g of t equals 1320000 times 1.0276 to the power of t. And if you did it that way, then you wouldn't have to worry about this conversion at the end. But you would have just been multiplying by a million at this step to get to that 1.32 million out there. So you have like two options there. Kind of pick your favorite, whichever one kind of makes more sense for you at the end. Let's move on to question number 6. So the amount of caffeine in your body decreases by 32% every 2 hours. So find the 2-hour decay factor. So decay factor, growth factor, the same formulas. Decay just means going down. So just reminding you what we did. So the 2-hour decay factor, growth factor. Actually, we're using the decay factor this time. I did say I was doing that. So decay factor this time, 1 minus 32 over 100 is equal to, what is it equal to? 0.68. All right. So letter B, this one is one of those higher level thinking questions that you might have to worry about. So the reason why it's a higher level thinking question is this is the 2-hour decay factor, which means this is 2 multiplications, and we want one of the 2 multiplications. So we need, this is 2 multiplications, and now we need one of the 2. Because you need one of the 2, that is a fractional exponent, 1 out of 2. So the correct decay factor for 1 hour is going to be 0.68 raised to the 1/2 power. So we are going to be taking that 0.68 and raising it to the 1 divided by 2 power, and you end up with 0.8246 as our 1 hour decay factor. And now we want to find that 1 hour percent change. Use that same formula we've been using all day. Percent change is 100 multiplied by 0.8246 minus 1. And that's going to be negative 17.54%. And that is a decrease. Or in other words, every hour, the amount of caffeine in your body will decrease by about 17%. So you can think about that. So you might be thinking, hey, 6 hours later, I got 0, but it doesn't quite really work that way with percent decay, as we're about to find out. In this 5-hour energy extra strength has 220 milligrams of caffeine. That is an accurate amount. Set up a function f that gives the amount of energy or amount of caffeine in your body in t hours after taking a 5-hour energy extra strength. So f of t is going to be equal to the initial amount, 220, multiplied by our 1 hour decay factor, 0.8246, raised to the power of t. And there you go. Use your function from part D. Find out how much caffeine is still in your system 5 hours after drinking a 5-hour energy extra strength. So how much do you have left after 5 hours? So let's find out. 220 multiplied by 0.8246 raised to the 5th power. So I'm just plugging all that into my calculator. Again, if you need help with this on your calculator, let me know. You will get 83.87 as the number there. You can go more decimals if you want to, but this is in milligrams. Just to give you an idea. So an average like Coca-Cola or a Dr. Pepper will have about 40 milligrams of caffeine. An average Red Bull will have about 80 milligrams of caffeine. So even 5 hours after your 5-hour energy extra strength, you still have a Red Bull's worth of caffeine in your system. So is it really only 5 hours? Probably actually more than that. They're probably just advertising 5 hours as the peak amount. but you still have to make sure that you have less. So it says F, it is common advice from doctors to avoid caffeine once there are fewer than 7 hours until bedtime. Using either your function or the 7-hour percent change, argue why doctors say to avoid caffeine once there are fewer hours till bedtime. So the idea was using your function, you could argue that we still have a Red Bull's worth of caffeine in your system, but I like using that 7-hour percent change. Let's figure that out. So the 7-hour percent change, our decay factor is going to be that 0.8246 raised to that 7th power. And that's going to be 0.2592. And therefore, our percent change after those 7 times would be 100 multiplied by 0.2592 minus 1. And that's going to be negative 74.08%. And that's a decrease. So that means after 7 hours, you can expect 74% of the caffeine to be gone. So that's it, actually. So even the 7 hours, honestly, maybe it's not quite enough. If you're somebody who had one of these 220 milligrams, right? 5-hour energy here, you know, you're still looking at 57 milligrams of caffeine after that time. So, I don't know. That's still over a Dr. Pepper's worth of caffeine. Just be careful is all I'm saying. Let's go on right here. We're moving up to question number 7. A particular credit card offers a 23.49% APR along with a 6 months no payment needed option. Austin gets his credit card and uses it to purchase $1,000 worth of stuff. What is the actual annual interest rate? So remember, whenever you have an APR question, you have your own specific formula. The actual growth factor is going to be 1 plus 23.49 divided by 100. That's divided by 12. That's raised to the 12th power. And you do have to type all that into your calculator. And again, that is how it actually works. This is how credit card companies get you, or one of the ways anyways. They are lying to you, and it's not actually a 23.49% APR. It is actually a reality of, looks like 1.2619 for the growth factor. Interest rate, that's a percentage. So our change in percent is actually 100 multiplied by 1.2619 minus 1, which is 26.19% as the actual interest rate. Don't need the word increase here. Obviously, it's increased. They're charging you more money. And now it says, after the 6-month grace period, how much does Austin owe? So yet again, let's use this new is equal to the old value. The old value is 1,000. The amount of dollars that he purchased here, multiplied by the growth factor, 1.2619. And that's going to be $1,261.90. Boom, boom, boom. Technically, if you use your calculator rounding, you would get 92 cents, and that's actually what the credit card companies would do. They would definitely charge you that extra 2 cents. So if you didn't round and you put a 1 here or a 2, definitely acceptable and still correct. For our very last question here, the minimum monthly payment will be $50 on this card, and interest will be reapplied at the end of each month. How much does Austin owe after 1 payment, 2 payments, 3 payments? How much are you going to have to do? So again, that amount owed originally, the amount owed there, I'm going to use the non-rounded version for this one. So if you have slightly different numbers on your answer, that's okay. So you paid 50. So you're subtracting that number. So you get 1211.92. So subtracting, taking that number and subtracting 50, but I messed up on my calculator. Once you've taken this new number, you're going to have 1211.92, and you are now going to reapply the interest. This is our new old, basically, and you're multiplying it by the growth factor again, and the growth factor is to the power of 1/12. So you're doing 1.2619 to the 1/12 power. And the reason why it is 1/12, this is 1 of 12 months. It is always a 1/12 when you're coming to these credit card situations. So it turns out after you plug this into your calculator, I need to go and grab this guy right there, raise it to the 1 divided by 12 power. If you do it correctly, your new amount of money is 1235.64. And again, your numbers might be slightly different because I'm using the no rounding whatsoever. If yours are slightly different, that's okay. And if you do this process 2 more times, this is after 1 month. 2 months, you will get to 1181.53. And 3 months, it will be 115. Yeah, 115.368. That's a dollar sign in front there. So, yeah, that's how long it takes. So you've done 3 payments of 50. And in terms of doing it in your calculator, I'm just doing this whole thing. Approximate, use a spreadsheet. I'm just gonna do it in the calculator here. So if you notice what I did is I plugged that in, minus 50. That's after, looks like this was after 1 payment. Oh, this was after 2 payments. Whoops, actually I did it too many times. The correct number here was 1235 was right. And then, oh, the next number here was supposed to be, I'm going to write it out more pretty. 1 month later, it was 1235.64. 2 months, it was 1208.85. And 3 months, it was 1181.53. 4 months was the next number. But the point is you would have to continuously hit enter on your calculator or use a spreadsheet to figure out how many months it is. So that was actually 3, 4. So 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. 34 months plus another $9. So 34 times 50 plus this 9.37. Austin is going to spend $1,700 on his $1,000 purchase if he doesn't pay off his credit cards right away. And that is why you want to convince people to pay credit cards immediately, so that you don't waste $700 going directly to some banker's pocket. Other than that, have a wonderful rest of your day. Have a wonderful rest of your week. See you guys later.